My study is entitled Limbic Hyperactivation During Processing of Neutral Facial Expressions in Children with Bipolar Disorder. This study was conducted and published by Rich and his colleagues in 2006. By 2006, all chronic mental illnesses present in adulthood were thought to be the result of disruptions in neural development during childhood. These researchers decided to look into pediatric bipolar disorder as a cause of neural developmental disruptions. Things like emotional responses, decision-making, personality expression, and determining good versus bad were shown to be affected by bipolar disorder through various parts in the brain. For this study, the researchers focused on the idea that children with bipolar disorder may mislabel facial emotions due to their emotional dysregulations. Thus, the researchers developed the hypotheses that participants with bipolar disorder, first, would report greater ratings of hostility and fear, second, have longer reaction times, and third, have greater activation in the brain in response to emotional tasks. 43 children aged 9 to 17 all viewed a randomized mixture of 32 faces. They were split up each with 8, so 8 were happy, angry, fearful, and then 8 were neutral. They then rated each of the faces on 3 different 5-point scales. The first was the level of hostility, as in how hostile is the face. The second was their individual fearful response, as in how afraid are you? And the third was nose width, as in how wide is the face's nose. The level of hostility and individual fearful response made up the emotional tasks, while the determination of nose width and the control conditions were the non-emotional tasks. During each trial, the researchers conducted fMRIs on the participants to monitor their brain activations. Results then compared rating scores, as well as reaction times and brain activation. The patients rated the neutral faces as more hostile than the controls, which demonstrated that children with bipolar disorder perceived facial expressions as more negative. They were also more likely to feel afraid as a result of this perception than the controls did. Secondly, for reaction times, the patients with bipolar disorder were slower to rate the hostility of the neutral faces than the controls. In other words, they took longer to respond to the questions when they related to the degree of hostility. There were no differences, though, between reaction times for rating fear, so both the patients and controls took approximately the same amount of time to answer questions when those questions pertained to their own degrees of fear. Lastly, the fMRI scans showed greater increases in brain activation in the patients as opposed to the controls. This meant that, while performing each of these tasks and answering each question, the brains of the patients were more active than the brains of the controls. Overall, the researchers' hypotheses were all supported except for the reaction time in rating individual fear. There were multiple limitations identified by these researchers. These included a high rate of comorbidity, medication effects, and a small sample size. Yet despite these, this study successfully illustrated the effect that pediatric bipolar disorder has on the brain. Nevertheless, further research still needs to be conducted concerning face processing in these patients. By doing this, causes of these functional impairments may be further illuminated in addition to potential therapeutic techniques.